I welcome all the students. Today we are going to learn one of the important line clipping algorithm, okay, which is known as Cohen Sutherland line clipping algorithm. Okay, so in initial session we have already learned the point viewing transformation, windowing. We have seen in the last session what is meant by the clipping operation, point clipping, what is the basic of the line clipping algorithm. Okay, now let us understand in today's discussion in detail, hey, how this Cohen Sutherland line clipping algorithm works. Okay, so our point of discussion is understanding of Cohen Sutherland line clipping algorithm. Okay, so when we complete this discussion, we may go for the one more algorithm, okay, and so on. Okay, so this is the remaining thing we will discuss in the next session. Okay, let us start understanding the Cohen Sutherland line clipping algorithm. See, this is the Cohen and Sutherland. Okay, these are the names of the scientists. Okay, who have designed this algorithm. So Cohen Sutherland. So the name is given for their algorithm as Cohen Sutherland line clipping algorithm. Okay, so these are Cohen and Sutherland. These are the names of the scientists who have designed this or developed this algorithm. Okay, now this particular algorithm, Cohen Sutherland line clipping algorithm. Cohen Sutherland line clipping algorithm is one of the oldest and most popular line clipping algorithm. So this comes under the one of the oldest and popular line clipping algorithm. So we are going to understand this algorithm, how it is used for the clipping the line. Okay. Now this method of Cohen-Sutherland line clipping algorithm, this method speeds up the processing of line segment by performing the initial test. Okay, so it is perform initial test that reduces the number of intersections that we are going to calculate. Okay, so generally this test is called as the visibility test. So initially it will perform the visibility test. Okay, and that will help us to reduce the number of intersection calculated or intersection that we need to calculate. Okay, now this Cohen-Sutherland line clipping algorithm uses one method, or they have derived one method which is called as endpoint codes. Okay, so they have defined this method or derived this method. The name of method is endpoint codes. Okay, now what is this endpoint code? So every line endpoint in a picture is assigned a 4-digit binary code. Means we are going to assign the endpoint of the line with a 4-digit binary code, and that code is called as the region code, or it is called as endpoint code. Okay, region code or endpoint code. Now that code identifies the location of the point. Okay, it identifies the location of the point relative to the boundaries of the clipping rectangle. So this endpoint code will help us to find out where exactly the endpoint of the line exists. Okay, or what is the region of that particular endpoint. Okay, relative to the clipping window. Okay, and that is we are going to find out with the help of the endpoint code. Okay, so these regions are set up in the reference to the boundaries as shown below. We are considering one next diagram to show. Okay, next slide we are going to see the diagram to understand how these regions are divided. Okay, so there are we can say 9 regions. The screen is divided into 9 regions. Okay, so we are considering which are these 9 regions. Okay, in the next diagram, each bit position of the point in the region code is used to indicate one of the 4 relative coordinate position. Okay, so each bit position. So how many bit I am having binary code? I am having the 4-digit binary code. Okay, we have mentioned here. So it uses endpoint code uses 4-digit binary code, and the each bit position of the point in the region code is used to indicate one of the four relative coordinate positions, okay, of the point with respect to. So I'm just going to have this 4 bit with respect to the clipping window. So I'm assuming that my clipping window or my clip window rectangle is having the left edge, it is having the right edge, it is having the top edge, and it is having the bottom edge. Okay, so I'm going to find out the each bit position, okay, in the point, each bit position of the point in the region code is find, or we are going to calculate it with respect to the all these left, right, top and bottom edges. Okay, so this endpoint coding method and the visibility test, okay, endpoint coding method and visibility test is, I can say, the heart of the Cohen Sutherland line clipping algorithm. Okay, so understand this endpoint code, how exactly these regions are there and how we are going to set the bit, okay, with the help of the next slide. Okay, see in the next slide, okay, we can find it here by numbering the bit position. Okay, we are giving the number, okay, binary number, maybe 0 and 1, by numbering the bit position in the region code as 1 through 4. So I'm just considering that the region code is 1, bit number 1, 2, 3, 4. Okay, from right side to left side. Okay, so I consider it is from right to left. Okay, this is my right side, this is my left side, so I'm just moving in this direction, right to left. Okay, 4 bits can be correlated with the bit position as, so I'm going to set the bit 1, so bit 1 is related to the left window or the left edge of the window, bit 2 is with respect to the right window or right edge of the window, bit 3 is with the bottom or the below edge of the window, and the bit 4 is for the above or top. Okay, so below means it is bottom, above means it is the top edge of the window. Okay, now how this is defined, how exactly it is defined, let us understand this diagram. Okay, so this diagram is very important. Now we can find that, suppose I consider this is my complete screen. See what I'm saying, I'm just showing that this is my complete screen where I want to display the picture. Okay, so this is my complete screen. Now this complete screen is now divided into 9 regions. Okay, number of regions are 9, 1 2 3 4 5 6 7 8 9. It is divided into the 9 region and we are calling it as a 9 region code. Okay, and this is nothing but, okay, I'm just showing it here. See, this is my the clipping window. All of you are getting me? So this is my clipping window. Obviously in my clipping window you can find this is my left edge of the window. Getting me? This is my uh, right edge of the window. This is my, I call it as the bottom edge of this window. B stands for the bottom edge, and obviously this is going to be my, I can call it as the top edge of the window. Okay, so this is my endpoint codes, this is my window, and these are my different edges. Okay, now you can find when, now how these 4 bits are considered. The 4 bits are considered from the right to left. So this is my first bit. Okay, I hope all of you cleared with this is my first bit. Okay, this is my first bit. Okay, this is my second bit, this is my third bit of the endpoint code, and this is my fourth bit of the endpoint code. It is clear? So this is my first, second, third, fourth, right to left. Okay, I'm considering. Now my right bit number 1. Okay, when I'm going to set bit the number 1, when my endpoint code or when my endpoint of the line lies to the left side. Okay, it is going to lie to the left side. Okay, so if it is left side, now you can see that this is my left edge. Okay, this is my left edge of the window. So anything outside this left, you can find that the bit, first bit is set to 1. This is 1, this bit is also 1, this bit is also 1. Why it is to set this bit number 1 is if my point lies to the left of the window or left side of the window. Okay, Similarly, I will go for my bit number 2 is set if it is to the right side. So this is my, you can find that this is my right edge of the window. Okay, and if the point lies above this right edge, okay, you can find that this window is there, then we are going to set this second bit. Okay, so this is my second bit set here. This is also my second bit is 1. Here also my second bit is set to 1, and so on. Getting me? So I'm going to set the second bit if my point is greater than the right edge, or it is outside the right edge of the window. Similarly, bit 3 is set if it is below or the bottom. So you can find that the third bit, no, this is my bottom edge. Okay, and you can find that I'm going to set this third bit 1. The third bit is 1. The third bit you can find it as a 1, because all these points, anything in this region, okay, anything which is in this region lies to the below of the window edge or the below the bottom edge. Okay, similarly bit 4 is above. Above means it is top, so this is my top edge of the window, and you can find that anything lies above this top edge, the fourth bit is set. So this is 1, you can find this is 1, you can find this bit is also set to 1. Okay, so this is nothing but whatever just now we have seen, this is called as the ninth region endpoint code, and it will shows how we are going to set this bit. Okay, now continue with continuation of this discussion. What we considered, a value 1 in any bit position indicate that the point is in that relative position. Point is in that relative position, just now we have seen. Otherwise the bit position is set to 0. Okay, now for example you can find the, this is my complete window. Okay, now if this is my point, see what I'm saying, this is my one point. Okay, now what about this point? This point, all the endpoint code values are 0 0 0, because this point is not uh, uh, not at the left side of the left edge, not at the greater than right edge, not less than bottom edge, not greater than the top edge. Okay, so all these values are 0 0 0. Okay, you can find it. Similarly, okay, suppose I take the example of this. Okay, suppose this is the example. Suppose my point is this. Okay, this is my point. Okay, I assume that this is my point. Okay, P. Okay, suppose I consider this is my point P. Now this point, what is going to happen? This point is outside the left edge as well as outside the bottom edge. So left edge means first bit is set. You can find here. This is set to 1. Whether it is outside the right edge, no, so that's why second bit is 0. Whether it is below bottom edge, yes, the bit is set to 1. Whether it is above, this point is above top edge, no, so it is 0. So the endpoint code of this point is 0 1 0 1. So appropriately we are going to set the point. Okay, so we continue our discussion of the endpoint code, because as I told, this endpoint code will help us to speed up the process, or it will help us to find out the visibility of the line also. Okay, so I just continue my discussion. Okay, and I just go to the next slide. Okay, we may going to keep this diagram also in the next slide, so that it will be easy for us to find out the endpoint code. Okay, so I hope all of you understood. When I'm going to set the bit number 1, if my point is outside the left edge, I'm going to set the bit number 2 if my point is outside the right edge. When I'm going to set the bit number 3, my point is outside the below, okay, or less than the bottom edge, okay, that I'm considering. I will go for bit number 4 if I will the point is above the top edge, okay, and so on. And outside this window, all these points are outside the window, we are going to set it. Okay, so just let us continue our discussion or the algorithm. Okay, so here what I'm going to consider is, if a point is, now just now we have seen, that's why I told we are going to keep this diagram with us, because this diagram indicates the ninth region and how we are going to set the bit position over here. Okay, in the Cohen Sutherland line clipping algorithm. Now if a point is within the clipping window, then the region code is 0 0 0. Just now we have seen. Okay, suppose this is my point. Okay, this is my pixel, or this is my point. Obviously this point is inside this window, and it is inside means it is not outside the left, not outside the right, not outside the bottom, not outside the top. Okay, so what is going to happen in this case? Its value will be 0 0 0. Okay, consider one more example. A point that is below, okay, the point is that is below and to the left of the rectangle. So I just consider, just now we have considered this example. Okay, suppose this is my point. Okay, I said this is my point, or the point which lies inside this particular region. Okay, here what is going to happen? The point is below the bottom edge of the window, or below the window, as well as it is outside the left edge also. Okay, so that's why it is having the region code 0101. Is it clear? Now suppose I consider my point is here. Okay, suppose I consider this is my point. Okay, I'm just showing this as the point with the help of some brown color. Suppose this is my point. Now what will happen to this? This point is, okay, this point is above, or it is outside the right edge. Okay, because this is my right edge of the window. For right edge, I'm going to set this particular second bit to 1. This is 0, not left. Okay, no, it is 1. This is whether this point is below bottom, no. Whether the point is above top, no. So I'm just going to set this value to 0010. So accordingly, okay, remember, accordingly we are going to set all these endpoints of the line. Okay, so for example, I just considered, suppose this is my line. Okay, consider this is the starting point of the line. Okay, I consider this is, suppose I considered the point is P1. Okay, I consider this is the point is P2. Okay, and this is my line P1 to P2, and this is my line. Okay, so what is the P1 code? P1 endpoint code, it will be 000001. What is P2 code? 0000. Okay, that we have to find out. Okay, let us continue our discussion. Bit values in the region code are determined by comparing the endpoint coordinate values x and y to the clipping boundary. Now this P1 is also having the value x1, y1. This is also x2, y2, suppose. Then how I can calculate? I can calculate how I can find out whether the point P1 is outside the left edge, or whether it is below the bottom edge, whether it is above the top edge. How I can find out? So I have to find out some fixed condition for it. Okay, I'm going to find out the fixed condition for this. And what is my fixed condition? Yes, I'm going to set the bit number 1. See, this is my bit number 1. I'm again explaining this. This is my bit number 1. This is also my bit number 1. Okay, now when I am going to set this bit number 1, bit number 1 is set to 1, or I'm going to set this value to 1 if the value of the x, assume the point is having the x and y coordinate value, or the point is represented by x and y, then if the x is less than xw minimum. Okay, so this xw minimum is nothing but it is the left edge. Okay, so this is my left edge, or any point which is less than this left edge. Okay, less than this x value is less than xw minimum. This is my xw minimum, this is my xw maximum, means it is right. Okay, this is my yw minimum, this is my yw maximum. Yw minimum means it is bottom edge, and yw maximum means it is my top edge. Okay, so I'm just need to put this 4 condition to find out the endpoint code of the line. Getting me? What is my, when I'm going to set the bit number 2, similarly. Okay, similarly, my bit number 2 is set to 1 if x value is greater than xw maximum. Xw maximum means it is greater than right edge. Okay, and left and right edge is represented with the help of the x value. Okay, because this is my x edge, and this is my x axis, and this is my y axis. Okay, similarly, when I'm going to set the bit 3 is set, the bit 3 is set to 1 if the y is less than yw minimum. Getting me? If the value of y is less than yw minimum, means if the y value is less than y bottom. Getting me? If my value of y is less than y bottom, so y is less than yw minimum, then I'm going to set the bit number 3. I'm going to set the bit number 4. Getting me? I'm going to set the bit number 4 is set to 1 if the y is greater than yw maximum. Yw maximum is nothing but it is my top edge. Okay, so this is what we are going to consider. XW minimum indicate left edge, XW maximum indicate right edge, YW minimum indicate bottom edge, and YW maximum indicate the top edge of my clipping window. Okay, and accordingly we are going to set this bit, and accordingly we will be in a position to get the correct endpoint code value of the line. Okay, now the next question comes, or you may ask the question, what we are going to do after finding the endpoint code. Once I found the endpoint code, how I am going to use this endpoint code. Okay, so the answer to this question is we are going to use the endpoint code to check the visibility test. Okay, it is used for the visibility test. Okay, now how we can do this? What is the code? What is the condition? What is the method for this that we are going to learn it from the next slide? Okay, so I'm just moving to the next slide to understand how these endpoint codes are used to check the visibility. That was the reason I have written the heading as visibility test using the endpoint codes. Now, what is meant by visibility test? The visibility test indicate that I have to find out. I think we have learned in the previous session or the previous lecture that first we have to find out whether the line is totally invisible, whether the line is totally visible, or whether the line is partial. Okay, so whenever the line is given for the clipping, we have to find out the visibility of the line. Okay, what is the three possibility of the visibility of the line or visibility test? The line may be totally visible or totally inside. The line is totally invisible, means the line is totally outside, or it is partial. Okay, so let us understand how we can perform this visibility test. Okay, with the help of the this 9th region codes or with the help of this endpoint codes. Getting me? So let us understand this. I'm just moving to the point over here. Okay, now what I'm considering here, how the logic is applied. Okay, understand the method over here. If the bit by bit logical and, see what is the method, bit by bit logical and, this is logical and operation of the two endpoint codes is not zero. Okay, two endpoint codes is not zero, then the line is totally invisible and it is trivially rejected. Okay, so what is the condition? To find out whether the line is totally invisible, I want to find out whether the line is totally invisible or it is going to, obviously it is invisible means it is rejected, it is clipped. Okay, but how to find out? We have to take a bit by bit logical and operation of the two endpoint codes, and after taking this logical and operation, I want the code is not zero. Okay, if the code is not zero, okay, if the code is 000 means it is not totally, not zero means it is having at least one value, one bit is 1, indicate it is not zero, then the line is totally invisible. Let us understand whether it is correct, whatever I am saying, whether it is correct or not. Okay, so what I have to do in this case, getting me, suppose I just showing, okay, I just change the color over here so that it will be easy for you to understand the line. Suppose I take the green color. Okay, now see that this is my line. Okay, this is my first end point of the line, maybe the P1. This is starting point, this may be the second point of the line. So this is my line. You may consider this is my P1. I'm just showing this as an example, and this is my P2. Getting me? I hope all of you understood it easily. This is my P1 and this is my P2 point of the line. Okay, this is my line. Okay, now this line, what is going to happen? I have to find out whether the line is totally invisible. I have to find out whether the line is totally invisible. What I need to do, I will take the endpoint code. What is the endpoint code of P1? 0001. Okay, suppose I write it here. Suppose the endpoint code of this line is 0 0 0 and 1. Okay, this is for P1. What is P2 code? Code is 0 1 0 and 1. Okay, now what I have to do after knowing these two endpoint codes, I have to take a logical AND operation. So I'm taking the logical AND operation. So 1 AND with 1, 1 1 answer is 1, 0 0 answer is 0, 0 AND with 0, 0 AND with 1 the answer is 0 because this is my AND operation. Okay, you know the truth table of the logical AND operation, and 0 0 it is 0. Okay, so what is my result? Just check what is my result. My result is not 0. Okay, whether I'm having the result as all 0 0 0, no. So what this indicate? It indicate that this particular line, is totally invisible. If my logical and bit by bit logical and operation is not 0, okay, here it is not 0, indicate the line is totally invisible. Okay, I hope all of you understood it. Now if the line, if my answer is 0 0 0, okay, means answer is not 0. See what we have written, if the answer is not 0, line is totally invisible. Otherwise what will happen? Otherwise there are two options now. Okay, so this is my first visibility test. What is my first case? Totally invisible. Okay, otherwise what will happen? The line may be totally visible or the line may be partial. My line may be totally visible or it may be partial. Now again, how to find out whether the line is totally visible? Okay, I'm just putting the question mark here. Okay, whether the line is totally visible or whether the line is partial. Okay, how to find out? Okay, for this we are having the next condition which is very simple. Okay, now see, when I come in the otherwise case, when I come to this otherwise, indicate that my line is not totally invisible. Okay, if it is not totally invisible, it may be totally visible or it may be partial. Now when my line is totally visible, I think it is more easy for us to understand. Okay, suppose I put this is my line. I think I will need to change the color because this is already having the blue background. Okay, I take the our color, brown color. See, this is my line. Okay, I'm drawing the line over here. This is my line having the endpoint P1. Look at the 9 region code. We are having the line. This is my P1 and this is my P2. Getting me? This is my P1 and this is my P2. Okay, now what is the P1 code? It is 000. What is the P2 code? Also 000. I think it is easy for us to find out whether the line is totally visible. Okay, this is what I have mentioned here. Now we can test for totally visible line. Okay, now we can test for totally visible line. Okay, when the line is totally visible, if both endpoint codes of the line are 000. Okay, here P1 endpoint code, all 4 are. What is the P2 endpoint code? All 000. Okay, so it is very simple. If the both endpoint codes of the line are 000, it indicates that the line is totally visible. Okay, so the line is totally visible, and you are knowing that if the line is totally visible, I think there is no need to go for any clipping. The line is saved or the line is on the screen and we exit. Okay, if the line is totally invisible, what we are going to do, we are going to reject that line or we are not going to save the line. This particular line, for example, is totally invisible, it is rejected. Okay, it is not displayed on the screen. Getting me? Now if this condition is failed, means my line is not totally invisible, my line is not totally visible, then what it means? My line is partial. Okay, so that is what I have written here. Otherwise my line is considered as a partial line. Okay, then my line is partial. Okay, so this is what the visibility test that we are going to do under the Cohen Sutherland line clipping algorithm. Okay, so what is the procedure to find out the visibility of the line? What we have to find out, we have to first find out the endpoint codes. Okay, we have to find out endpoint codes of the line. Okay, now shall I take the example of the visible line? Yes, it is. I have taken. This is my totally visible line. This is my totally invisible line. Getting me? Now, if I take the example of partial line, Okay, suppose my line is partial. Okay, suppose I take this is my line is something like this. Okay, this is my line. Okay, I have drawn the line. Assume this is my P1 code and assume this is my P2 code. Getting me? So this is my P1 code and this is my P2 code. What is the P1 code value? See, my P1 code value is, okay, I just write it here for your simplicity. See, this is my line which is partial. Okay, now why my line is partial? Suppose the P1 point code is 0, 0, 0 and 0. Okay, so I'm having 4 zeros for P1. What is the P2 code line? For P2 code is 0, 0, 1, 0. So this is my 0. Getting me? This is 0. See, this is my P2 code. Okay, 0, 0, 1 and okay. Now if I take the logical AND operation of this, okay, 0 and with 0, answer is 0. 0 and with 1, answer is 0. 0 and with 0, answer is 0. Again 0 and with 0, I'm having the answer is 0. So what is my result? My result is all zeros are there. Now what is my condition? If the bit by bit logical AND of the two endpoint code is not 0, then only totally visible, but my answer is all zeros. My code is 0, 0. What it means? The line may be totally invisible or it may be partial. Okay, but what is the condition for totally visible line? My line is totally visible if both the endpoint codes of the line are 0, 0. This is my P1 endpoint code. Okay, my P1 endpoint code is 0, 0, 0, but my P2 endpoint code is not 0, 0, 0. It is having the value 0, 0, 1, 0. So my line is not totally visible and that indicates that my line is partial. Okay, so this is what help us to determine the visibility of the line. Okay, and now once we know the visibility of the line, okay, what is our action plan? My action plan is, if the line is totally visible, then it is rejected. If the line is totally invisible, it is rejected. If my line is totally visible, then it is saved and displayed on the screen as it is. But if my line is partial, okay, if my line is partial, what I have to do? Obviously I have to find out the intersection point of the line. Okay, we have to calculate the intersection point of the line. So this is the next step of my Cohen Sutherland line sweeping algorithm. Okay, so I'm just moving to the next slide to understand, to explain the how we calculate the intersection point. See here, I just read this here. For partial lines, okay, we find out the intersection point of the line with window edges. So all partial line, if I found that in my visibility test, I come to know that my line was partial. My line is partial. What I have to do? I have to find out the intersection point of the line with the window edges. Okay. Now it may happen that my line may intersect more than one window edge, okay, which is shown in the below diagram. Okay. Now let us understand this particular diagram. Here in this diagram, the lines extending from one coordinate region to another region may passes through the clipping window. Okay, so it is now, see, my one point is in this region, another point is in this region, and it is going to intersect to the different edges of the line, or they may intersect clipping boundaries without entering the window. Okay, so they are intersecting but without entering into the window. Now in those cases also, okay, so we can find, means it may be the case, in such case we have to find out the intersection point. Okay, now before understanding this particular line or this line, I just take one simple example, okay, as we have seen. Okay, what is my example? Suppose this is my line. Okay, consider this is my line P1. Okay, and this is my line having the endpoint P2. So line endpoints are P1 and P2. Okay, obviously using this is my line P1 and P2. Using my visibility test, I came to know that this line is partial. Okay, my line P1 to P2 is now partial. Okay, so what I have to do? I have to find out the intersection point of the line with the window edge. So whether P1 and P2 is going to intersect this left edge of the, I think we have seen this is my left edge, okay, of the window. This is my right edge of the window, getting me? This is my bottom edge of the window, getting me? And this will be my top edge of my window, getting me? This is my top edge of the window. So this is my left, right, bottom and top edge of the window. So this P1 P2 line intersect with the left edge? No. It is going to intersect with the right edge? Yes. Okay, so what we have to find out? We have to find out this intersection point. Okay, so in Cohen Sutherland line clipping algorithm, after the visibility test and I found that the line is partial, what I'm going to do is I'm going to find out the intersection point of the line, okay, with the window edges. And once I find out this intersection point, what this indicate my line is divided. Suppose I call this is my intersection point, then my line is divided into two parts. This is my, and now if I consider the line P2 to this, okay, to this, indicate that this line is totally invisible or totally outside, and this part is clipped or this part is rejected. So this part is removed. So line from this to this is removed and I will retain only this part. Okay, and I can perform the clipping operation. Okay, but now in another example, or we can consider this particular line in the diagram. Suppose I consider the diagram this particular line. So it is having, this is my starting point of the line, okay, and this is my end point of the line. So this is my P1 here and this is my P2, okay. But this line has now this line, just now we have seen the example, intersect only one edge, but this line intersect more than one edge. There may be three edges. You can find that it is the first intersection point of the line with the left edge. This is the intersection point of the line. So this is my second intersection point. This is my first intersection point. This is my second intersection point. This is my first intersection point of the line with left edge. This is my intersection point with the top edge, and this is my intersection point of the line with bottom edge. Getting me? So this line intersect the three edges of the window. Okay, obviously initially this intersection point I just going to remove this part of the line. Okay, for next intersection I am going to remove this particular part of the line. So whatever I have shown with the green color indicate that this part is removed, okay, because this particular part is outside my window. If it is outside, this is rejected. Next I am finding this as my intersection point. Okay, so this particular part of the line is rejected or it is clipped or it is removed now. So what is visible to me? Only the point from this to this, the line is visible, and the remaining part of the line is clipped now or it is removed from the we can say the output or the display window. Okay, so this is what the Cohen Sutherland line clipping algorithm does. Okay, so it is, I can say that the Cohen Sutherland line clipping algorithm is having three steps. Okay, in general, what is the step number one? In step number one, we have to find out the endpoint codes of the line. Okay, in the step number two, we have to check the visibility of the line. We have to find out whether the line is totally invisible, line is totally visible, or if it is partial. Okay, so if it is totally invisible, the line is rejected. If it is totally visible, the complete line is drawn without clipping. And if it is partial, okay, if the line is partial, then and then only we will go to find out the intersection point of the line with the window edges as shown in this particular diagram or the example. Okay, so I hope, and after finding the intersection point, obviously the part which is outside the intersection point or the edge will be discarded or rejected or clipped, and only the part which is inside the window will be preserved, okay, or it is displayed. So just now I have shown in this example. Okay, so this green color indicate that the part of the line which is outside up to this intersection point and it is rejected. Here also up to this intersection point other part is rejected and we are going to just clip the part which is visible or which is inside the window. Okay, now this is what we are having about the Cohen Sutherland line clipping algorithm. Okay, but now the student may ask the question, or we need to find out, if I'm writing down the C program for Cohen Sutherland line clipping algorithm, then I must know the formula to find out intersection point. Okay, so I have to find out what is the formula I should use, how I can find out the intersection point of the line. Getting me? Now to understand this, how to find out the intersection point of the line, or what is the equation, what is the formula for it, I'm just moving to the next slide just to understand the, I think we have already cleared with the procedure of the Cohen Sutherland line clipping algorithm. We know what is the algorithm, 3 steps are there. Okay, how the algorithm works. But now we just want to mention the equation for the to find intersection point. Okay, so that's why I'm just moving to the next slide now. Okay, so this is the last slide of our today's session, which shows how to find out the intersection point. Okay, the intersection point with the clipping window edge can be calculated using the slope intercept formula or the form of the line equation. So using the slope of the line and slope intercept with the window edge, okay, with the help of the line equation, we are going to find out the intersection point. Okay, so let us understand this. Okay, for a line, so I consider a line with the endpoint coordinates x1, y1 and x2, y2. So you may consider that this is the line is having the value p1. So p1 is having x1, y1, and my second endpoint of the line is p2. Okay, so my second endpoint of the line is p2 having the coordinate x2 comma y2. So x1, y1 indicate the p1 point and the x2, y2 indicate the p2 point. Okay, p1 point and the p2 point. Okay, now the y coordinate of the intersection point with the vertical boundary can be obtained with the calculation. Okay, so how I can find out the y coordinate value. So what is my formula that I'm having to use is y is equal to y1 plus m bracket x minus x1. Okay, so how I can find out the intersection point? See, my intersection point, okay, so I just mentioned here, my intersection point is having the value x comma y. Okay, my intersection point is having the value x comma y. How to find out the y value using the equation? So y value of the intersection point is y is equal to y1 plus m bracket x minus x1. All of you know what is mean by the m here, where the x value is set. So what is the x value is set? X value is set either to hw minimum. Everyone knows hw minimum is my left edge of the window, or hw maximum. Hw maximum is my right edge of my window. Okay, and the slope of the line is calculated. So where x is set to either, suppose I want to check whether it's the intersection point with the left edge, then I will use x is equal to hw minimum. If I want to find out intersection point of the line with the right edge, then I use the xw maximum. X is equal to xw maximum, and the slope of the line is calculated. Everyone knows what is the slope of the line. The slope of line is calculated as m is equal to y2 minus y1 upon x2 minus x1. Simply delta y upon delta x. Okay, so that is my slope of the line that we are going to consider. M is the slope of the line, which is equal to y2 minus y1 upon x2 minus x1. Okay, now similarly, now I have written the formula to find out the y coordinate value of the intersection point. So this is the y value of the intersection point. Similarly, okay, we are looking for the intersection with horizontal boundaries. The x coordinate can be calculated as, so x value of the intersection point can be calculated using the similar formula. And what is the formula that I am going to use for this is x is equal to x1 plus y minus y1 divided by m. Okay, so if you just solve this particular equation and you can want to find out about x, we can find that x is equal to x1 plus y minus y1 upon m. Okay, now here what is the y to be set? So y to be set to the maybe the bottom edge or maybe to the top edge. Okay, so that is what we have mentioned here, where the y value, okay, I want to find out the x value of the intersection point. Now I want to find out the x value of the intersection point. So this is the x value of the intersection point, and the formula for this is x is equal to x1 plus y minus y1 upon m. And what is the y value? The y is set either to yw minimum. What is yw minimum? Yw minimum indicate my bottom edge. Getting me? We indicate bottom edge, or yw is set to yw maximum, which is my top edge. So if I want to find out intersection of the line with bottom edge, then y is equal to yw minimum. If I want to find out the intersection of the point with the top edge, okay, I want to find out the intersection point of the line with top edge, then my y value is equal to, in this formula, the y is equal to yw maximum. Okay, so this is what the formula or the equation that we can use to find out the intersection point of the line with the clipping window edge. Okay, and everyone already knows what is the steps that I'm having to follow in the Cohen Sutherland line clipping algorithm is. I think I told there are the three basic steps or the main steps. Step number one, find out the endpoint code of the line. Suppose line is P1 to P2, find out the endpoint code of the P1, find out the endpoint code of the P2. Step number two, we go for visibility test. Okay, so what we are going to do, we are going to take the bit by bit and operation of the endpoint codes of the line, P1 endpoint code and P2 endpoint code, and from that, based on it, we can find out whether the line is totally invisible, whether the line is totally visible, or the line is partial. Okay, if the line is totally invisible, then it is rejected. If the line is totally visible, then it is completely drawn. And if the line is partial, then whatever just now we have learned, these are the different formulas that we are having. By using the formulas, we can calculate the intersection point of the line with the window edge, and appropriately we are going to clip the outside part of the line, and we just preserve the part which is inside the window. Okay, so this is what that we are having, or this is what all about the Cohen Sutherland line clipping algorithm. It is one of the oldest algorithm, okay, and it is generally used everywhere for to perform the line clipping operation. Okay, I hope we have learned in all respect, in all details of the Cohen Sutherland line clipping algorithm, and all of you also have enjoyed it. Okay, so we end our session here. So thank you all the students.